Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. And now we'll assign the value, that is 217, to the timer 0 register. After assigning the value to timer 0 register, that is 217, now we'll select the bits of option register, that is option REG equals to, here we can see the selection bits for option register. Here we have 3 bits, that is PS0, PS1 and PS2, to assign the rate to the prescaler. And here we can find the values, that is from 000 to 111 or 0 to 7. We'll select the value 5, that is 101, to have a prescaler rate, that is 1:64. We'll select PSC bit as 0. We'll select T0 SE bit as 0. T0 CS bit will be 0. Interrupt H bit will be 0. And port B pull-up register bit will also be 0. So here we have the binary value that we will assign to the option REG. Now we'll assign the value to option REG, that is 0B 0000 0101, and now we'll select 3 interlocking bit of IntCon register, that is global interrupt enable underscore bit equals to 1, peripheral interrupt enable bit, that is PEIE underscore bit equals to 1, and timer 0 interrupt enable bit will also be 1, that is T0IE underscore bit equals to 1. Now we have completed all the assignments which are required to generate the interrupt of 1 millisecond, and now we'll start the while loop, that is while 1, and we'll write the while loop routine between these two braces. Here we will write port B equals to inverse of port B, and we'll call a delay of 500 millisecond, that is delay underscore millisecond 500. Here we have written a routine to toggle the port B with a delay of 500 millisecond. Now we'll write the interrupt service routine before main program, and here we will write the interrupt service routine. Here we will write, that is void interrupt and we'll write the interrupt service routine between these two braces. Here we will check if the timer 0 interrupt flag is 1, so we'll write if T0IF underscore bit equals 1, if the timer 0 interrupt flag bit will be 1, so the program will come into this if condition, and here we will toggle the test LED, and here we will write test LED control C and control V equals to inverse of test LED bit, that is inverse of test LED, and now we'll reload the timer 0 register, that is TMR0 equals to 217. Before leaving the interrupt service routine, we'll clear the status of timer 0 interrupt flag, so we'll write T0IF underscore bit equals to 0. The interrupt service routine will be executed after every 1 millisecond, and it will toggle the test LED which is connected on port C3. Now we'll compile the program and we'll observe the result on our prototype. So I'll compile the program. Here we can see The program is compiled successfully and there is no error, and hex file is generated. Now we'll download the program to the microcontroller and we'll observe the result of our program. First, I'll select the power supply jumper setting to provide the power to these LEDs. Here I've selected the power supply jumper setting. Now I'll connect the PIC3 programmer with this prototype. Now I'll run the program for PIC3 programmer. I'll go to the file, import hex, and here we have the hex file, that is timer 0 interrupt service routine project. Okay. Now we'll download the hex file to the microcontroller. Okay, programming successful. Now I'll remove the PIC3 programmer from prototype. Now we'll power up the prototype and we'll observe the result of our program. Here we can check all 8 LEDs are blinking with a delay of 500 milliseconds, that is 0.5 second. Now we'll check the status of port RC3, that is pin number 18 of this microcontroller. Here we have the oscilloscope. Here I have connected the ground of the oscilloscope with the body of LM7805, which is ground. Now we'll check the frequency on pin number 18 of this microcontroller. Here we can check the frequency is 497 Hz. Now we'll check the time duration between rising edge and falling edge of this frequency. Here we can check the delta time is 1 millisecond. It means that the interrupt is coming after every 1 millisecond. Now we'll write the program to display the counter on multiplex 7-segment display. As you know that all 4 anodes are connected with the lower enable of the port D, that is RD0, RD1, RD2 and RD3, and all 8 segments are connected with port B, that is RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7, and we have connected segment A with RB0, segment B, segment C, D, E, F, G and dot point. And here we have the segments of a 7-segment display, that is A, B, C, D, E, F, G and dot point. The segment A, B, C, D, E, F and G and dot point. To display the number 0 on this 7-segment display, only G and dot point will be off and all other segments will be on. So we can write G will be 0 and dot point will be 0 and all other segments will be on. And the equivalent hex number will be 3F, and it will form the number that is 0. Here we can write the equivalent hex number of 4-bit binary, that is A, B, C and D, and here we can find the combinations of a 4-bit binary number, that is 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6 and 7. Now 8, 9, 10, 11, 12, 13, 14 and 15. Here the equivalent hex number is 0, 1, 2, 3, 4, 5, 7, 8, 9, A, B, C, D, E and F. Now we can write the equivalent hex number with the help of this table. To display the number 1 on this 7 segment display, only B and C segments will be on and all other segments will be off. So we can write B and C will be on and all other segments will be off. Now the equivalent hex number is 0x03, which will display the number that is 1. Now to display the number 2, F, C and dot point will be off. So C will be 0, F will be 0 and dot point will be 0 and all other segments will be 1. And the equivalent hex number is 5B, that is 0x5B, and it will display the number that is 2. To display the number 3 on this 7 segment display, segment F, E and dot point will be off. So segment E will be off, F will be off and dot point will be off and all other segments will be 1. And the equivalent hex number is 4F, that is 0x4F, and will display the number that is 3. To display the number 4, segments A, E, D and dot point will be off. So we can write segment A will be off, segment D will be off, segment E will be off and dot point will be off and all other segments, that is B, C, F and G will be on. B, C, F and G, and the equivalent hex number is 66, that is 0x66, and it will display the number 4. To display the number 5, segment B, E and dot point will be off. So we can write B will be off, E will be off and dot point will be off and all other segments, that is A, F, G, C, D will be on. Segment A will be on, segment C will be on, segment D will be on, segment F will be on and segment G will be on, and equivalent hex number will be 6D, that is 0x6D, and it will display the number 5. To display the number 6, B and dot point will be off. So we can write B will be off and dot point will be off and all other segments will be on. And the equivalent hex number will be 7D, that is 0x7D, and it will display the number 6. To display the number 7, segment A, B and C will be on and all other segments will be off. So we can write A will be on, B will be on and C will be on and all other segments will be off. And the equivalent hex number is 07, that is 0x07, and it will display the number 7. To display the number 8, all segments will be on and the dot point will be off. So we can write and the equivalent hex number is 7F, that is 0x7F, and it will display the number 8. To display the number 9 on the 7 segment display, only segment E and dot point will be off. So we can write E will be off and dot point will be off and all other segments will be on, that is 1, 1, 1, 1, 1, 1, and the equivalent hex number is 6F, that is 0x6f, and it will display the number 9. So here we have find the equivalent hex number to display the decimal number on 7-segment display, and here we have the equivalent hex numbers. So we'll use these equivalent hex number to display the decimal number on 7-segment display.